Since the last video, I completed mid-game space science. I got deep space haulers pulling Naquitite from asteroid fields outside the solar system, and I ran into this weird thing. What the heck? Here are some highlights. For science, I launched some probes from the belt and some from orbit around the sun. I feel a little bit guilty that I haven't automated this, but each launch gives me enough data for 8,000 top-tier science, so launching a couple by hand once in a while feels like a lot less work than automating. I'm just going to live with feeling a little bit guilty. An alarm went off telling me that elevator cables aren't keeping up. If I run out of those, the space elevator crashes or something, and that sounds bad. Why did they stop? It's complicated, of course. They stopped building because I ran out of holmium cables, because I ran out of holmium, because my power infrastructure died on that colony, because uranium's recycling backed up because I ran out of iron ingots to convert uranium into fuel. With uranium recycling backed up, I couldn't remove spent fuel from my reactor, so I could no longer insert fuel, so no power. Oops. Sounds like Factorio, right? And iridium production on Mariel stopped because I set my signal receiver to listen to the wrong signal, and Mariel thought I had a lot of iridium when I was entirely out of it. And I forgot to filter these blank cards into recycling, which backed everything up. Meanwhile, I visited the other pyramids in my solar system. The Tesla gun is a bit OP. And then there's Aurea. I don't know how I'm going to get into that pyramid. Actually, I think I'll just delete the surface. Yeah, that's better. Easy peasy. In the last video, Michael Devlin 5101 asked if the return belt ever gets jammed with scrap. I said, so far, no. But you do need to have enough recyclers. Guess who didn't have enough blank card recycling? Upgrading to a quantum supercomputer doubles the speed. That'll fix it. Then I ran out of the uranium I need for science. So I head to the last mapped uranium deposit. My personal lasers and shields have also become quite OP. But if you get careless and, say, switch to satellite view when bugs are nearby, well, then you get what you deserve. Finally, time for the last in-game resource, Naquitite. It is well out of the solar system, so I designed a rocket fuel hauler that can barely make the trip. But it uses a ton of fuel and takes about 45 minutes one way. That's an hour and a half round trip. So I recycled that ship and built an ion engine-based hauler that carries 2 storehouses full of Naquitite and only takes 15 minutes each way. I traveled to a nearby solar system and launched some probes to map out pyramids there. And I got this weird message at Chrysalis. The message came from this thing that Factorio calls an enemy structure, so I was nervous. I approached cautiously, but it didn't attack. And I can't seem to target it. Oh, this is some kind of game controller. Okay, we will get back to this at the end. I thought this was an interesting view. I spent 50 hours getting to the first space science, then another 50 colonizing my Vulcanite world for the second space science. At 170 hours, I unlocked spaceships. I redid logistics with them, building a massive spaceport, and 65 hours later, finally started energy space science. 2 hours later, I unlocked space elevator and rebuilt the entire base from scratch. 45 hours later, I finally started biospace science. From there, I knocked out the next 7 space sciences quickly, but the top tier bioscience took me another 14 hours as I fixed all the production that could no longer keep up with demand. I tripled my iridium production, set up 3 new holmium refining blocks and 4 new Vitamelange refining blocks. Coolant wasn't keeping up, but Tier 2 radiators are 3 times faster, so that was easy enough to fix. And I redid much of the belt work so the inserters could saturate the belt to the hub and down to novice. Core mining backed up with copper ore, and novice ran out of stone. Now, when copper ore backs up, I trigger inefficient copper plate and green chip production. Inefficient iron and steel plates relieve iron ore backups. And that got me through mid-game space science. Lastly, I processed the Naquitite on Novice. You have to process it on the planet if you want to use production modules, and you do. Trains deliver exotic resources here, where inserters saturate 2 blue belts for processing. The Naquitite ore is crushed on site and sent to the LTN for pickup. The iridium powder byproduct is sent back to Mariel, which is already set up to process iridium. Even with heavy use of production modules, I'm only making 24 Naquitite ingots per 1700 ore. At a stack size of 10, that's only 71 ingots per shipload. Oh, and not only does Naquitite production require every other exotic resource, it also requires methane gas. So I set up another ship route to pick up methane ice from the asteroid belt. I convert the ice to gas and train it down to novice. I've been told my spaceport is intimidating. As an experiment, I kept the circuitry for this one to a minimum. But it doesn't listen to demand signals and only ships goods in one direction. Finally, back to this thing. This section will contain some spoilers, but I'll warn before revealing anything. Also, unless you plan to play this mod and happen to be a total math nerd, you might want to skip this part. It is really nerdy. But you aren't a nerd, you're just a guy killing some time watching a playthrough of a complicated factorial mod pack. Well, then again, you just might be a nerd. Welcome! First, spoiler warning, I'm going to interpret the confusing game instructions. It turns out they are not clear. So the text says that 3D vectors give 3/4 of a grid. This confused me because vectors are directional pointers, not locations. It turns out the 3 vectors given are coordinates, not vectors. The question is asking if the displayed grid is projected into 3D such that the 3 given corners have the coordinates shown, then what direction would you need to shoot a beam of light from the origin to hit the highlighted square? That explanation is still a bit confusing, and I was going to explain it with a simpler 2D version, but I found a great Reddit post by WebBugT that lets me explain it in 3D. Here is the same problem shown in 3D. Given the 3 points, top left, top right, and bottom left, marked as TL, TR, and BL here, give a direction vector that will hit the middle grid after passing through the origin. Looking down the x-axis, you can see the y and z will be 1/2, and the whole grid is at an x of 1. So, I enter those values and get a free fish. The game shows where my answer hits the grid, dead center. The first one was easy, but how hard do you expect to work for a fish? They get difficult, so I needed to figure out the math. Another warning, I am going to spoil the math if you keep watching. So if this kind of thing is fun for you, and you are still watching, so you're definitely a nerd, then maybe pause here until you figured it out. Or poured yourself a drink and decided you don't care. There are basically 2 halves to this problem. The first half is how to compute a vector to hit a specific location on the grid. That one will need the coordinates we've been given. The second half is what location are we trying to hit? That one will use the grid size and target cell information. First half, how to hit a specific location on the grid. If you've never studied vector algebra, you are unlikely to figure this one out. We know the top left coordinate. Now we need to know how much the coordinate changes when we go to the right and when we go down. To compute those delta vectors, we simply subtract one coordinate from the other. Now, top left plus delta right, I'm calling it dr, will equal top right. This is algebra, but with vectors. We want to go halfway to the right, and that will be TL plus half of dr. This makes sense since adding dr will get us all the way, and we just want to go half. Likewise, adding half of delta down gets us halfway down. It really is that simple, and that answer gets us a fish. For the second half of the problem, how do we know what our target is? For the first problem, it was obviously halfway to the right and halfway down, but what about this one? With a grid size of 7 in column 2, how far to the right is that? Well, it's halfway between the edges, and the 8 edges go from 0 out of 7 to 7 out of 7. Halfway between 1/7 and 2/7 is 3/14. Here's a general equation for any grid size. And this is what you get if you put it all together. The answer shown on the left is 100 times larger because I solved it using factorial circuits and they don't support floating point. Somehow I had forgotten that factorial circuits only support integral numbers. This is me trying to multiply by 0.5 and failing. After briefly considering going back to my original idea and writing it in Python, I realized I could do the math in fixed point. Basically that means that 100 is equal to 1. And this worked. I read the x, y, and z values by looking at the power pole, divided them by 100, and typed them in. 100 machine learning data cards. Not worth much, but the prizes get better. Prize 3, 100 significant data cards. Bullseye. For prize 4, I stopped dividing by 100 since the vector would still point in the same direction. Spidertron. Tier 9 efficiency module. Tier 9 speed. Tier 9 productivity. And ooh, 4 wide area beacons. Though not a bullseye anymore, I might need more decimals soon. A Naquitite processor? And... crap. Duh. Just to the right of the target. One more decimal probably would have done it, but I jumped to 6 for 10 arcospheres. Anyway, that is it for this episode. Meanwhile, I'm starting to work on deep space science. I've got the first level started, and it looks like I have more space probes to launch. So expect more guilt for not automating all the things next episode. There isn't much tech left, so next video should be the last. I'll get to play with arcospheres and plan to skip the normal victory in favor of the hidden epic victory. See you next time.